Hello friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Let's get started.
Hello viewers, today I'll show mechanism analysis of a door, how it will be opening and closing by using PTC Creo parametric. This type of application can be utilized for any kind of rotating device, suppose railways, and this opening and closing can be done when the speed of the railway is within a specific range. When it is very slow, in that case only this opening and closing can be done. Okay, the modeling has already been done using PTC Creo. Initially we start assembly, then after completing this assembly part we will go for mechanism analysis. We'll try to find out the velocity acceleration of different links. By the same time we'll find out the tracing of the curve also. Okay, so let's start from new. We start with assembly, and default usage should be checked out, and keeping the name of the project as assembly 005. Okay, and from the template we have to select millimeter Newton assembly design absolute. Okay, you have to start assembly from here, assemble, and you have to select the components one by one. Let us select part number 6, 7. Let us preview these things, what it is having. It is having part number 6 links, all other different links. This is 7, 8, this is the door, 10th, this is one crankshaft, this is the frame above the door. That one should be imported at the beginning, so let us take this one. This is the first component that should be in the default location. You can select this one as default. You can check it is done. Now for better understanding, we can color this one with a different color. Let us make this one with yellow color. Done. Next one, you have to select different components. Initially you have to select the door at the bottom of this one. You can select the door from assembly here. Door is part number 8. Let us select this one. Now for better assembling, we can drag it towards that component, and this one will be having some kind of slider connection. So we can select from here, from user defined it will be slider, and for sliding, two linear edges should be matched. You can select this edge should be matching with this edge, and again one faces should be there. That means you can select this face should be matching with this face. Done. One part is assembled. Now you can select another part. Okay, next we'll select the same component and that to be assembled at other location. Assemble. We'll select the same component, door, and that to be assembled at the other side. Definitely it will be slider connection. That means two different edges to be connected, and the faces should be aligned also. You're selecting this face should be aligned with this face. This is done. Now you can drag this one a little bit inside. That is not necessary. So the door is aligned. Next to that, we have to align different links. You can select from the assemble. Let us select part number 7. Open, and we can drag it towards that connecting location. This one will be having pin connection with the central part here, so you can join from here as a pin connection. For pin joint, you have to select that locations. This should be matched with this location, and finally the edges should be matched. The top surface of this one should be matching with the top surface of this one. This is done, right? Green check. Now another link should be added at this location, and here let us select the link. From here it will be part number 6. Open. Let us drag it toward the main location, and for better understanding we can make this one a little bit bigger. Again it will be pin connection. From the user defined you can select pin. So this pin should be attached with this hole. Now the faces should be aligned. Top face of this one should be aligned with the top face of this pin. Done. Now again another new set of connection should be made, and these two different pin locations should be attached together. So we are starting with new set. It will be pin connection. Then this pin should be meeting with this hole, and the surfaces need to be aligned. The top surface of this one should be aligned with this top surface. Done. Green check. Right. Exactly same way another link should be attached at this part. Let us select the same link again from assemble. Part number 6 is taken. Let us drag it towards the main location and orient this one a little bit. That is not necessary. That is for understanding. Again it will be pin connection. So from user defined we can select pin, and let us align this pin with this hole. Next to that the top surface should be meeting it together. This pin top surface should be meeting with the top surface of this link. It is done. Again new set of connection should be made with pin connection. So this pin joint should be meeting with this hole. Next to that the top surface of this pin should be meeting with the top surface of this link. Done. Again check. Now we can provide some color for better understanding. Let us provide red color at the central link, and let us provide green color to the other links. Done. And doors we can put some color again. Let us select this color for the door. Done. Let us see whether this mechanism is running or not. Still our mechanism is not complete. Yeah, it is running. It is okay, but it is not complete. You have to make this one complete with some other links. Next to that, you have to connect one connecting rod and crank at this location. So assemble from here and let us select part number 10 as the crank. Let us drag this one to the desired location here, and for better understanding we can rotate this one a little bit. This is not necessary, that is just for understanding only. What we'll do is, again we need one pin connection at this location, so we can drag this one towards the main connection. This one will be having pin joint, so from user defined we can select pin, and this pin surface should be meeting with this hole. Next to that meeting surfaces are needed also. This surface should be meeting with this top surface of the pin. It is done. Let us rotate this one a little bit. Fine. Next to that, we have to connect that connecting rod. So let us select that connecting rod from assemble. Connecting rod is part number 12. Let us open this one and drag it towards the main location. Let us make these lines clear. Next to that, you have to connect this connecting link. From user defined, you have to select the pin. Now this hole should be meeting with that pin at this location, and this side surface should be meeting with the back surface of the pin. It is done. Now a new set of connections should be made, and that should be meeting with this pin connection. The whole of this pin should be meeting with the back surface of this pin. Selected. Now the top surface of this pin should be meeting with back surface of this connecting rod. It is done. Green check. Let us provide color to this one. We'll provide blue color to this one. And again red color to the crank. Done. Let us check whether it is working or not. That will be done with using drag components. Yes, you can see the opening and closing can be done. Right, so it is okay. Next we have to go for analysis, right? So with the rotation of this crank, the opening and closing of the door can be made very easily, and this application can be utilized with any rotating device, like in railways it can be done, and the rotation of this one should not be continuous, as the wheel of the railway will be rotating with a specific amount of speed. When the speed is very less, when it is about to be stopped, during that time only this rotating device can be initiated, and with the rotation of the wheel as it is going to be stopped, the opening and closing of the doors can be made. Okay, Next to that, we'll start our mechanism analysis. With this mechanism analysis, we'll try to find out the velocity, acceleration of different links and also connecting reaction also. Let us start this mechanism analysis from applications, and we have to initiate mechanism analysis from here. Mechanism, we need to apply some servo motor at this rotating location. Let us select servo motors from here. Profile details, it will be having some kind of angular velocity with a specific velocity of, let us select 10 degrees per second. Let us select that location of that crank, and here the motor should be applied. Motor will be rotating with an angular velocity of 10 degrees per second. Green check. So motor is applied. Next to that, we have to go for a mechanism analysis by starting from dynamic analysis. And here in dynamic analysis, we're taking the duration of this mechanism to be 40 seconds. Frame rate we're considering to be 30. And as it is a dynamic analysis, we select motors, and motor is motor number 1, and external load should be selected also. It will be gravity and frictional capability should be enabled. Let us run this mechanism for 40 seconds, right? Let us run it. You can see the mechanism is running very smoothly. Done. Next to that, you have to go for playback. With playback, we can vary the speed and frame count also. Let us increase the speed and frame size also. Let's start checking this mechanism. Now we can capture this motion with a specific resolution, and we're keeping this one saved. By browsing it here at a specific location, we can save this one with a specific name of, suppose, mechanism analysis. We'll save this mechanism analysis in the form of an animation. Next to that, we'll go for mechanism analysis. That means we'll find out velocity, acceleration, and different options like connecting reactions, etc. for different links. It is done. Now we can close it, and we'll go for mechanism analysis. Okay. So for mechanism analysis, we have to start from measures, and by keeping this analysis definition open, we have to start for mechanism analysis. Let us start initially with the velocity analysis. We have to find out the velocity of the connecting rod. Let us select that location, the velocity at this location. We can find out velocity at this location. Let us find out velocity at this location. Okay. We got the velocity as 54.58 degrees per second. Next to that, we have to find out acceleration at this location also. You can rename this one as velocity of connecting rod. Okay, done. Next to that, we have to find out acceleration at this location. So we can select from here, and instead of position, we can provide this one as acceleration. Let us select that location. Okay, done. And we can rename this one as acceleration of connecting rod. Done. Acceleration is 0.25 degrees per second square. Next to that, we have to find out velocity of the door. By the same way, you can find out all the velocity acceleration of different links. Let us find out the velocity of the door. Instead of position, we select velocity, and this is the door where it is connected with the different links. Selected. Okay, and you can rename this one as door velocity. Door velocity, you can say it is 69.21 degrees per second. And finally, we'll find out acceleration of the door also. Instead of position, we'll select acceleration, and you select the location of the door, that is here. Okay, acceleration is 0.998 degrees per second square, and we can rename this one as acceleration of door. Okay, acceleration is 0.998 degrees per second square. Similarly, you can find out all the velocity, acceleration and different parts like continuation, momentum, etc. for different links together. Now we want to show all these graphs separately. So you can select the graphs together also. Let us select that velocity of connecting rod initially. This graph shows velocities of connecting rod, and it is showing that after 5 seconds its velocity is maximum, and after 17.5 seconds its velocity becomes 0. So by seeing this graph, we can control the velocity of the door. That is when it will be closed and when it will be opened. That can be viewed from this graph. Okay. Next to that, we'll see the acceleration of the door. This is the, you can see, dynamics analysis, velocity of connecting rod with different times. You can see. Next to that, we will see that acceleration of connecting rod from here. This is the acceleration of connecting rod. It has got maximum acceleration when time equal to 2.5 seconds here, and again when the time is equal to 37.5 seconds, acceleration is maximum, and it is minimum at this location. Okay. Similarly, we can plot all these things together. Just make the graph. In a single graph, we can have all these plots. First one is acceleration of connecting rod. Second one is acceleration of door. Then next one actually velocity of door and velocity of connecting rod. Right? We can plot these things separately also, and we can plot this together also. Right? In the same graph also we can plot these two things. That can be done. From this graph we can have a better control of this mechanism. Right? Let us close this one. Next to that, we have to go for trace curve. That will come from analysis here, and select trace curve. Initially, we have to select that mechanism definition to be selected, and let us select that connecting rod location here. Let us preview this. It is showing that this is the tracing curve of this crank as it is rotating in the circular way. This is the tracing curve. Similarly, for tracing curve for other locations also we can find out. Let us find out tracing curve of this location. Let us select that analysis definition 1, and with respect to that one, we will select the tracing curve of different links. Select this part and preview. So it is showing this is the tracing curve of this link. This tracing curve is indicated by the violet colored curve, right? This way you can find out the tracing curve of any specific links at any specific location. Okay. Let us close this one. This is all about our mechanism analysis of a door, how it will be opening and closing. This application can be utilized to any rotating device, like in railways also it can be utilized when the rotation of the crank will be providing as the input of this motion, and this input velocity can be controlled when the device will be having some specific speed. When it is about to be stopped during that time, this velocity can be utilized as the opening and closing of that door. Okay, thank you so much for watching this video. Thank you again. Bye.
If you like this video, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.